Welcome to Demolition Worker, where we explore the most massive engineering disasters and the incredible efforts required to clean up the wreckage. In January 2012, the luxury cruise ship Costa Concordia struck a reef near Giglio Island, initiating a massive maritime disaster. The vessel, weighing over 114,000 tons, capsized and came to rest precariously on its starboard side. This tragic event claimed 32 lives and left a massive steel monument of destruction lying in pristine Mediterranean waters. Because of its location in a protected marine sanctuary, leaving the wreck to rot was absolutely not an acceptable option. Salvage. Experts from around the world gathered to devise a plan to remove this colossal hazard without destroying the ecosystem. The sheer size of the ship made traditional salvage methods completely useless, requiring unprecedented engineering solutions and immense technical creativity. Engineers faced the daunting task of uprighting a vessel that was longer than 3 football fields combined and severely damaged. Before any physical work could begin, teams had to stabilize the ship to prevent it from sliding into deeper waters. Divers worked tirelessly to secure the hull to the rocky seabed using massive steel cables and heavy concrete anchor blocks. Advanced terrestrial laser scanning technology was deployed to capture the precise outer geometry of the exposed parts of the wreck. Simultaneously, high-resolution sonar systems mapped the complex underwater topography and the heavily damaged sections of the entire submerged hull. These detailed datasets were merged to create a highly accurate digital twin of the damaged ship on modern supercomputers. Using this virtual model, engineers simulated various stresses and structural dynamics to predict how the ship would react to movement. Every calculation had to be perfect because a single structural failure could cause the entire ship to split in half. The aground, a classic technique scaled up to an unprecedented level never before attempted in human history. Rotating the ship upright using a system of giant pivots, massive cables, and immense hydraulic pulling force. To support the ship once upright, workers had to construct a massive artificial seabed consisting of 6 giant steel platforms. Deep into the granite seabed to install solid steel pillars that would support these massive platforms. Flat as Sal. Flat, I'm leaving you with Chris Brown, would act as a flat table to hold the ship's weight and prevent it from sinking further. In addition to the platforms, engineers prepared giant bags filled with special grout to fill the gaps under the hull. The next step involved fabricating 36 massive steel boxes known as spunsons, which would be welded to the hull. These spunsons were built in Italian shipyards and transported to the wreck site on giant barges under strict schedules. Each individual spunson was as tall as an 11-story building and weighed hundreds of tons of solid structural steel to rotate and eventually refloat the damaged cruise ship. Giant structures required absolute precision as they had to withstand immense physical forces during the rotation process. These spunsons would initially be filled with water to provide ballast, helping to push the ship down during parbuckling. Later, they would be emptied of water and filled with air to provide the necessary buoyancy to refloat the vessel. Huge hydraulic strand jacks were installed on top of the spunsons to pull the massive steel cables during rotation. The cabling and system involving miles of high-strength steel wires tensioned to exact specifications. Every single cable was monitored by computer systems to ensure that tension was distributed evenly across the ship's frame. A dedicated control room was built on a nearby barge, serving as the brain of the entire salvage operation. Engineers in the control room monitored hundreds of sensors, measuring structural stress, tilt angles, and hydraulic pressure in real time. In September 2013, after many months of preparation, the command was given to begin the historic parbuckling operation. The hydraulic jacks began to pull with a pull force of over 6,000 tons, slowly tensioning the massive steel cables. That's it for me. Rachel Cavers hit. For the first few hours, there was no visible movement as the ship remained stuck to the reef's rocks. The cameras captured the first signs of movement as the massive hull slowly separated from the granite seabed. The tension on the cables was carefully adjusted to prevent the ship from twisting or breaking under its own weight. As the ship rotated, the water inside the portside sponsons acted as a counterweight, stabilizing the entire movement. The operation proceeded at a snail's pace, moving only a few degrees per hour to ensure maximum structural safety. Throughout the entire night, searchlights illuminated the dramatic scene as the rusted starboard side of the ship slowly emerged. The newly exposed side of the ship was heavily crushed and covered in marine growth, showing the force of the impact. After 19 hours of intense tension, the Costa Concordia was finally sitting completely upright on its artificial underwater platform. The success of the Parbuckling phase was celebrated worldwide as a major triumph of modern engineering and collaborative teamwork. However, the ship was still half submerged, and the next phase of the operation was about to begin immediately. Workers now had to install another set of 15 sponsons to the starboard side, which was previously underwater. This task was extremely challenging because the starboard side was heavily deformed and required custom-built steel attachment points. Specialized divers worked in extremely hazardous conditions to clear debris and weld support structures to the damaged starboard hull. These commercial divers utilized advanced saturation diving techniques, allowing them to work at depth for extended time periods. They were equipped with specialized dive view cameras and direct communication links to the surface. Live video feeds from the divers were transmitted via fiber optic cables to the Salvage team's main control center. Divers' primary mission was to safely explore the flooded interior of the luxury liner and locate valuable assets. Areas, including the ship's safe deposit boxes, secure vaults, and high-end luxury jewelry boutiques. I'm leaving you with Chris Brown, navigating the dark, upside-down corridors of the sunken ship was incredibly dangerous, with floating furniture and collapsing ceilings. Despite the risks, divers successfully recovered valuable paintings, sculptures, and historical artifacts that decorated the ship's main passenger halls. They also retrieved critical navigation equipment, ship logs, and advanced electronic systems from the bridge for investigation purposes. Every recovered item was carefully cataloged, cleaned, and secured under armed guard to prevent any looting or damage. Valuable personal belongings of the passengers were also recovered to be returned to their actual rightful owners later on. With the starboard sponsons finally installed, engineers prepared for the highly critical refloating phase of the project. Powerful air compressors began pumping air into the 36 sponsons, slowly pushing the heavy water out of them. The displacement of water created massive buoyant force, slowly lifting the giant steel hull off the underwater steel platforms. July 23, 2014, the Costa Concordia was officially afloat, once again fully ready for its final journey. Fleet of powerful tugboats connected to the ship, preparing to tow the massive wreck to the port of Genoa. The journey spanned 200 miles across the Mediterranean Sea, moving at a very slow and extremely cautious pace. Monitoring vessels escorted the convoy, ready to respond to any potential leaks of fuel or other hazardous chemicals. Fortunately, the transit was completed without any major incidents, and the ship arrived safely at the Genoa shipyard. The arrival in Genoa marked the official beginning of one of the largest marine recycling operations in industrial history. Highly specialized dismantling facility was prepared to process the massive amounts of structural steel and other materials. The first stage of dismantling involved removing all remaining internal furniture, carpets, wood, and various plastic materials. Hundreds of workers stripped the interior, separating hazardous materials from recyclable ones under very strict environmental regulations. Once the interior was completely cleared, the structural dismantling of the ship's massive steel superstructure could finally begin. Giant hydraulic shears and cutting torches were used to slice the upper decks into small, manageable pieces of metal. These massive steel sections were lifted off the ship using heavy-duty cranes and transferred to nearby processing yards. The steel from the hull was of exceptionally high quality, making it the global recycling industry. Over 50,000 tons of high-grade steel were recovered and sent to local smelting plants for immediate processing. This recycled steel was transformed into new structural beams, reinforcing bars and raw materials for various construction projects. In addition to steel, workers recovered the ship's massive bronze propellers, with each propeller weighing dozens of tons. These bronze propellers were melted down to reclaim valuable copper and tin, which are highly prized industrial metals. The ship's massive diesel engines and generators were also carefully dismantled to salvage valuable copper wiring and heavy components. Miles of safe electrical cabling were stripped to extract high-purity copper, which was then sold to electronics manufacturers. Valuable metals like titanium, brass, and aluminum were also carefully separated, sorted, and prepared for industrial auction. The recovered luxury items, including precious artwork and jewelry, were sent to prestigious auction houses in Milan. Collectors from around the world bid on these unique artifacts, raising millions of dollars to offset the salvage costs. The scrap metal auction attracted global recycling conglomerates, resulting in highly competitive bidding for all the materials. The total value of recovered metals and materials exceeded $40 million, providing some welcome financial recovery. However, this was only a small fraction of the total salvage and dismantling cost, which exceeded $2 billion. Despite the immense cost, the project clearly demonstrated that even the largest ships can be safely recovered and recycled, prevented a major ecological diesel disaster, protecting the pristine marine environment of Giglio Island. The seafloor, where the ship had rested for 2 years, was carefully cleaned and restored to its natural state. Biologists monitored the local marine life, noting a rapid recovery of the underwater ecosystem after the ship's successful removal. The lessons learned from this unprecedented salvage operation have truly revolutionized modern maritime rescue and engineering techniques. Today, salvage companies worldwide use the technologies developed during this project to handle other highly complex shipwrecks. Serves as a Costa Concordia reminder of human error and incredible modern engineering resilience. It highlights how in global cooperation can meticulous planning overcome the most daunting of industrial challenges. The massive ship is now completely gone, but its legacy lives on in the annals of modern engineering history. The transformation of a tragic wreck into valuable industrial resources showcases the power of modern recycling and circular economy. Thank you for watching Demolition Worker. Please subscribe for more incredible stories of engineering, dismantling, and massive salvage operations.